Good morning, friends. Hope you are enjoying my video and your life both. Today, in the series of sequence and series, this is my fourth lecture and it will be on sum of first n terms of geometric progression, that is Sn of GP. So let us start. Sn of GP. If A is first term and R is common ratio of a GP, then prove that sum of first n terms of GP is Sn is equal to A into bracket R raised to n minus 1 upon R minus 1 if R is greater than 1. And it is same as A into 1 minus R raised to n upon 1 minus R if R is less than 1. And it is n into A if R is equal to 1. See the proof of this. Let A, AR, AR square, AR cube, AR raised to n minus 1 be n terms of GP. Therefore, sum of n terms Sn is what? A plus AR plus AR square plus AR cube plus AR raised to n minus 2, this is n minus 1th term, plus AR raised to n minus 1, which is nth term. Write this as equation number 1. To find Sn of GP, we multiply by common ratio. So multiplying equation 1 by R. So we'll get Rsn is equal to AR square, AR cube. Here it will give you what? AR raised to n minus 1 plus AR raised to n. This is equation number 2. Case 1. When R is greater than 1. When R is greater than 1, then Rsn will be what? Larger than Sn. Rsn will be larger than Sn. So what we will do? Equation 2 minus equation 1 will do. equation 1. So we'll give you what? RSN minus Sn is equal to AR plus AR square, AR cube and so on, AR is to n minus 1 plus AR is to n. From this we'll subtract A plus AR square up to AR is to n minus 1. So on left hand side we will take Sn common. So R minus 1 into Sn is equal to, now from AR to AR raised to n minus 1 will get cancelled. What is left? AR raised to n minus A. AR raised to n minus A. So Sn will be what? A common. R raised to n minus 1 and this R minus 1 you divide. This is when R is greater than 1. Second case is what? If R is less than 1. When common ratio is less than 1, then RSN will be smaller than Sn. So from equation 1 we'll subtract equation 2. Equation 1 minus equation 2 will give you Sn minus Rsn, and this side you will get A minus AR raised to n. So 1 minus Rsn, A common, 1 minus R raised to n. So Sn is what? A into 1 minus R raised to n upon 1 minus R. This is when R is what? Is smaller than 1. And case 3 is what? When R is equal to 1. So equation 1 becomes, when R is 1, this equation will become what? Sn is equal to A plus A into 1 is what? A into 1 square is A into 1 cube is what? A plus A into 1 plus A into 1 square plus so on A into 1 raised to n minus 1. A plus A plus A. How many A's are there? Number of A's will be n because number of terms are n. So it is what? N into A is the formula. Next very important formula for sum of infinite GP. If A, AR square, AR cube dot, this is nth term of, and it is not stopping at nth term, it is keep on moving. Then it is called infinite GP. Now we have to find out sum of infinite GP. And just now we derived Sn, that is sum of n terms of GP. Now n is what? Approaching to infinity. That is what we have to find out. Is what? A into R raised to n minus 1 upon R minus 1 when R is greater than 1. or it is a into 1 minus r raised to n upon 1 minus r when r is less than 1. Let us find sum of infinite GP in both the cases. Case 1. When r is what? Greater than 1. Whenever r is greater than 1, then r raised to n will approach to infinity when n approaches to infinity. Therefore, S infinity will become a into, now r raised to n is approaching to infinity, minus 1 divided by r minus 1. Infinity minus 1 will give you what? Infinity. In that you are multiplying by a will be infinity, divided by r minus 1 will still be infinity. So this implies sum of infinite GP does not exist when r is greater than 1. Let us take case 2. If modulus r is what? Less than 1. Modulus r is less than 1 means what? Minus 1 less than r less than 1. As n approaches to infinity, in this case, r raised to n will approach to 0. Therefore, sum of infinite geometric series will be what? A into 1 minus 0 upon 1 minus r will give you what? A upon. Therefore, S infinity will exist when modulus r less than 1, and in this case sum of infinite GP is what? A upon 1 minus r. So we'll do some problems based on Sn of GP. So in this first is what? Find the sum of x plus y plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube and so on to n number of terms. Sn is what? X plus y plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube to n terms. In this case, we'll multiply divide by x minus y. So 1 upon x minus y into bracket x minus y into x plus y plus x minus y into x square plus xy plus y square plus x minus y into x cube plus x square y plus xy square plus y cube and continue till n terms and close the bracket. which is nothing but 1 upon x minus y. This is what? X square minus y square. And this is factor of x cube minus y cube. And this is factor of x raised to 4 minus y raised to 4. And so on to n terms. Now from this we'll separate it. 1 upon x minus y. In the first bracket we'll write x square plus x cube plus x raised to 4 to n terms minus common. In other bracket you'll get y square plus y cube plus y raised to 4 to n terms. Now this is in GP with first term x square and common ratio x. So first term into x raised to n minus 1 upon x minus 1 minus, again this is y square into y raised to n minus 1 upon y minus 1. So this is Sn of the given series. Second question is what? Find sum of n terms of series, not GP, n terms of series. When terms are added, then it is what? Series. Series this. Sn is what? 4 by 3 plus 10 by 9 plus 28 by 27 plus so on to n terms. This 4 by 3 can be written as 1 plus 1 by 3. 10 by 9 is what? 1 plus 1 by 9. 28 by 27 is what? 1 plus 27 by, 1 plus 1 by 27. Plus so on to n terms. So there are like this n brackets and each bracket contains 1. So sum of 1 from each bracket will be what? N plus, then remaining will take together 1 by 3 plus 1 by 9 plus 1 by 27 and so on to n terms. Now this is in GP whose first term is 1 by 3 and common ratio also 1 by 3 and 1 by 3 is less than 1. So its sum is what? A into 1 minus r raised to n upon 1 minus r. So n plus 1 by 3, 1 minus 1 upon 3 raised to n. 1 minus 1 by 3 is what? 2 by 3. 3 will get cancelled. You will get n plus 1 upon 2 into bracket 1 minus 1 upon 3 raised to n is the sum. Question number 3 is, for a GP, sum of first 3 terms is 125 and sum of next 3 terms is 27. Find the value of r. Let A be first term and R be common ratio. of GP according to problem T1 plus T2 plus T3 125 and T4 plus T5 plus T6 is 27. Therefore, this is what? S3, sum of first three terms. And now this will not give any formula. Formula is what? From 1 to 6 term. So what we'll do? In this we'll add T1 plus T2 plus T3 plus T4 plus T5 plus T6 will give you what? 125 plus 27. So S3 is what? 125, and now this will be what? S6 is 152. Now by formula S3 is what? A into R cube minus 1 upon R minus 1 is 125, and S6 is what? A into R raised to 6 minus 1 upon R minus 1 is equal to 152. Now we'll divide this equation by this. So consider A into R raised to 6 minus 1 upon divided by A into R cube minus 1 upon R minus 1. 152 upon 125. A upon R minus 1 will get cancelled. What is left? R cube minus 6 upon, R raised to 6 minus 1 upon R cube minus 1 is equal to 152 upon the factors of numerator are R cube minus 1 into R cube plus 1 divided by R cube minus 1 is equal to 152 upon, so R cube plus 1 is what? 152 upon 125. Transfer 1 on that side. So R cube will be what? 152 upon 125 minus 1. So R cube is what? 27 upon 125. 3 by 5 cube. Therefore R will be what? 3 upon 5. Question number 4 is find the sum to n terms of 3 plus 33 plus 333 plus so on. Consider three plus 33 plus 333 to n terms. In this case, we will take 3 common. So we'll get 1 plus 11 plus 111 to n terms. Our aim is what? To make this as what? 9 plus 99 plus 999. To get that, we will divide by 9 and multiply by 9. So 9 plus 99 plus 999 and so on to n terms. 3 by 9 is what? 1 by 3. And 9 can be written as 10 minus 1. 99 is what? 10 square minus 1. 10 cube minus 1. And so on. Nth term will become what? 10 raised to n minus 1. How many brackets are there? N brackets are there. And each bracket contains minus 1. So what we will do? Sum of all minus 1s is what? Minus n. And this will write in one bracket. 10 plus 10 square plus 10 cube plus 10 raised to n minus n. Now this is n terms of sum of n terms of GP. First term 10, common ratio also 10. So its sum is what? A into r raised to n minus 1 upon r minus 1 minus n. 10 into 10 raised to n minus 1 upon 9. You can take 9 outside. So 1 by 3 into 9. In bracket you will get 10 into 10 raised to n minus 1 minus 9n. So which is what? 1 by 27 into 10 into 10 raised to n minus 1 minus 9n. In such cases, our aim is what? To make 999. If it is 8, 88, 888, we will take 8 common and then multiply, divide by 9. If it is 5, 55, 555 and so on, then take 5 common and next step you multiply and divide by 9. So 5 by 9 will be outside. Find the sum to n terms of 0.7, 0.77 plus 0.777 and so on. Consider Sn is what? 0.7 plus 0.77 plus 0.777. These problems are not directly based on GP, but we had to convert them in geometric progression form. So we had to follow certain techniques in all the problems whatever we did today. वो सब कन्वर्जन वाले थे. किसी में 1 upon x minus y मल्टीप्लाई डिवाइड किया, ठीक है, तो किसी में 4/3 वाले में 1 प्लस किया एंड देन वी आर गेटिंग जीपी. सो यू हैव टू थिंक लाइक दैट. तो इसमें भी क्या करेंगे? फर्स्ट विल टेक 7 कॉमन. So that will give 0.1 plus 0.11 plus 0.111. 2 n terms. Then we'll make 0.9. For that, divide by 9, multiply by 9. 2 n terms. Now this can be converted as 1 minus 0.1 will give 0.9. 1 minus 0.01. 1 minus 0.001. 2 n terms. So it is 7 by 9. There are total n brackets because n terms are there. For each term, 1 bracket is there. and in each bracket will get 1. So 1 plus 1 plus 1 n times will give you what? N minus common 0.1 plus 0.01 plus 0.001 2 n terms. Now this is in GP with first term 0.1 and common ratio also 0.1. 7 by 9 into bracket n minus a into 1 minus r raised to n upon 1 minus r. Seven by 9 into bracket n minus 0.1 1 minus 1 by 10 raised to n 0.9. 7 by 9 into n minus 1 by 9 into 1 minus 1 upon 10 raised to n. If you want, you can multiply 7 by 9. 7n by 9 minus 7 upon 81 into bracket 1 upon 10 raised to n. If SPR are sum, product and sum of reciprocals of n terms of GP respectively, then prove that P square is equal to S by R raised to n. Look here. Let AR square, AR raised to n minus 1 be first n terms of GP. S is what? Sum A plus AR square plus AR raised to n minus 1. By formula it is what? A into R raised to n minus 1 upon R minus 1. In this case, I took R greater than 1. This is S. P is what? Product. A into AR into AR square into AR cube into AR raised to n minus 1. Like this, there are n brackets. If you count this as also one bracket. And each bracket has got A. So product of A will be what? A raised to n. R powers will get added. 1 plus 2 plus 3 plus n minus 1. This you can find out by sum of first n minus 1 natural number, or even you can find out by Sn minus 1 of GAP, arithmetic progression. So its sum is what? Now here number of term is what? N minus 1 divided by 2 into first term plus last term. So A raised to n, R raised to n minus 1 into n divided by 2. This is product P of first n terms of GP. And R is what? Sum of reciprocals 1 upon A plus 1 upon AR plus 1 upon AR cube plus 1 upon AR raised to, and this is also in R in GP with first term 1 upon A and common ratio one upon R. Here I took R greater than 1. So 1 upon R will be less than 1. So sum formula is what? First term into 1 minus common ratio is what? 1 by R raised to n upon 1 minus common ratio is what? 1 by R. So this will give you 1 upon A 1 minus 1 upon R raised to n upon R minus 1 upon R. This R will go up, A will come down, and this is what? R raised to n minus 1 upon R raised to n. One R will get cancelled, so we'll get R raised to n minus 1 upon A into, this will give you R raised to n minus 1 into R minus 1. This is reciprocal R. Now we will find out P square. P square will be what? A raised to n R raised to n into n minus 1 upon 2 square will give you what? A raised to 2n, power of power gets multiplied, and here also power will get multiplied, 2 will get cancelled. So R raised to n into n minus 1. This right equation star. Now we'll go to what? S upon R raised to n. Consider S upon R raised to n. S is what? A into R raised to n minus 1 upon divided by R is what? R raised to n minus 1 upon A R raised to n minus 1 R minus 1 raised to n. Now see, R raised to n minus 1 upon R minus 1 will get cancelled. This will go up. So it will give you what? A square into R raised to n minus 1 raised to n. Now power of power gets multiplied will give you what? A raised to 2n R raised to n into n minus 1. Write this as equation double star. You can see star and double star. From star and double star we get P square is equal to S upon R raised to n. If Sn, S2n, S3n be sum of first n terms, 2n terms and 3n terms of GP, then prove that Sn into S3n minus S2n is equal to S2n minus Sn the whole square. Let A be first term and R be common ratio of GP. So Sn will be what? a into r raised to n minus 1 upon r minus 1. S to n is what? A into r raised to 2n minus 1 upon, and S3n will be what? A into r raised to 3n minus 1 upon r minus 1. Consider Sn into S3n minus S2n. Sn is what? A into r raised to n minus 1 upon S3n is what? A into r raised to minus S2n is what? A into r raised to 2n minus 1 upon. Now between these two we can take a upon r minus 1 common. So which is equal to a into r raised to n minus 1 upon into a upon r minus 1. So in bracket you will get r raised to 3n minus 1 minus r raised to 2n minus 1 will give you what? A square r raised to n minus 1 upon r minus 1 square. In bracket you will get r raised to 3n r raised to 2n. Again we'll take r raised to 2n common. If you take r raised to 2n common, you'll get r raised to n minus 1. So this is nothing but a square into r raised to 2n into r raised to n minus 1 the whole square upon r minus 1 the whole square. This is right equation star. Consider s to n minus sn the whole square. S to n is what? A into r raised to 2n minus 1 upon r minus 1 minus a into r raised to n minus 1 upon the whole square. Now between these two we will take a into a upon r minus 1 common. A upon r minus 1 common. So in bracket you will get r raised to 2n minus 1 minus r raised to n plus 1 the whole square, which is what? A square upon r minus 1 square into r raised to 2n minus 1 r raised to n the whole square. Take r raised to n common, will give you r raised to n minus 1 the whole square will give you what? A square upon r minus 1 square. This will give you r raised to 2n into r raised to n minus 1 the whole square, which is nothing but a square r raised to 2n r raised to n minus 1 square upon r minus 1 square equation double star. From star and double star we get Sn into S3n minus S2n is equal to S2n minus Sn the whole square. This is what we had to prove. Thank you very much.